Welcome to the video on Triangle Inequalities, Chapter 4, Lesson 3. In every triangle, the small side is opposite the small angle. The large side is opposite the large angle. So at this point, what I need you to understand is that there is a relationship between the angles and the sides that it creates. And it really is kind of like opposite that. Sometimes I talk about it being like a flashlight, like you have the flashlights over here and it's beaming this light on this wall. And so depending on the angle that the light is beaming, you could have high beams or you could have low beams. And so the angle over here is going to have a relationship with the side that's on the opposite side. So angle and then the side that it's creating. And that's ultimately what this is saying, that the small angle is going to produce the small side, larger angle will produce the larger side. And then since it's a triangle, there's only 3 sides, so the other one is just there in the middle. So if you look at this example 1, it says to list the angles from least to greatest, but if you see, we're actually given side information. So we have 15, 20, and 22, 2, 5, and 6, but the question is asking you to list the angles. So what's important to remember here is that the small angles will create the small side. So if I start with the small side of 15, then that means that the angle, that flashlight that has to create it, angle A, is going to be the smallest angle. And then the largest side of 22, the flashlight that creates that side is going to be angle B. And so a lot of times I'll kind of do it like this, like where the 15 is coming from angle A, then the 22 is coming from angle B, and angle C is producing that 20 side. And so that's where that relationship is. So if we were going to list them out, listing the angles from least to greatest, the 15 is the smallest, so that's angle A. Then the middle one, the only one that's left there in the middle would be angle C. And then the biggest side was angle B. Okay, so that's what we're looking at doing. It's just that there is a relationship between the angles and the sides that are created from those angles. Okay, so now we're asked to list the sides from least to greatest and we're given angle information. So I don't have any idea what these side lengths are, but I know that they're angle measures because they're these 62 degrees, 58 degrees, 60 degrees. They're in the angle spaces and they have the little degree markings there. So it's the same relationship. Small angle creates the small side, large angle creates the large side, and then you just have whichever one is in the middle. So in this case, my smallest angle is 58 degrees, and so it's producing this side. And this is just where it becomes important for you to be able to name that side as XY. So going back to chapter 2, making sure that we know how to use the proper names. After the 58 comes the 60 degree angle. So then that's shooting across over here and creating side XZ. Okay, and I am going to use that notation with the segment, but ultimately you would not lose points if you didn't. Just know that technically it should. And 62 degrees is the biggest angle, so it's going to produce the largest side, which is YZ. And again, when we're naming sides, you can go either way. So XY or YX, XZ or ZX, YZ or ZY. Okay, so this one gets a little bit more interesting just because now we have variables in it, but the variables are actually pretty straightforward because there's just X's, there's just multiplication and no adding, but I'm just gonna deal with it the same way as if there was some addition and subtraction. The point is that we know there's 180 degrees in the triangle, and so these 3 angles, the 2X plus the 3X plus the 4X equals 180 degrees, and so you could solve this for X. That's 9x equals 180, so x equals 20. And so you'd plug that back in and figure out that this is a 40 degree angle, this is an 80 degree angle, and this is a 60 degree angle. And so once you solve for x and plug it back in to find the angle measures, then you can specifically find the side lengths because your answer should be about your side lengths. The shortest side is coming from the smallest angle, so opposite of that, it has to shoot across it. It has to be the flashlight that's beaming onto the wall. So that 40 degree angle is beaming onto side GN. So that's the smallest side, and yeah, just that's the smallest side. The next angle would be angle G. Shooting across is going to be creating side BN. And And again, GN, NG, BN, NB, that doesn't matter. And then the last one, I guess I'll use black here, 80 degrees shooting across to this long side over there. So GB or BG is going to be the longest side. This particular problem gets done in the exact same way. It's just that you're going to have more algebra to do to solve it, but we know that the angles are 180 degrees. We technically only have to name the largest side, but we still have to figure out the largest angle. So we're going to need to set up the equation where adding all three of these angle measures together, setting them equal to 180 and solving that, figuring out X, figuring out the angle measures, and then the largest angle will give the largest side. The answer is going to be coming up in the next screen, but I just like the math is the same as the 2x, 3x, and 4x. It's just longer expressions to make the algebra a little bit trickier. The riddle time practice in your notebook is one of the assignments for today. At this point, you could essentially take time to do the riddle time practice. The riddle time practice uses this material where you're just relating the angle measures to the side lengths. The lesson clearly goes on. The video is not done, but the riddle time practice focuses on the relationship between the angles and the side lengths, okay? Make sure you turn that in. Okay, the next part of this lesson focuses on what sides can actually physically create a triangle, because it does matter. So you can see there, it says that the sum of the measures of any two sides of a triangle must be greater than the measure of the third side. It has to be able to actually make a triangle, okay? So I have 3 sticks here, okay, 3 sticks, 3 different lengths. That doesn't matter, okay? 3 different lengths doesn't matter. What matters is that when I add any two together, it ends up being bigger than the third side. So I added these two together, put them on top of each other, added them together. They're bigger than the third side. These two are bigger than this one. And then these two are definitely bigger than this one. So the point is that these can create a triangle, okay? They can physically create a triangle. Now, if I switch out a side and make it shorter, and now these two sides, my two shortest sides added together, they are not bigger than my third side. So 2 sides added together, they're not bigger than my third side. See how they're shorter? It's not bigger than my third side. These cannot make a triangle, like vertex to vertex, like top to top. Yes, I could do this, but that's not a triangle. That's a triangle with an extended side. If I actually tried to go make a triangle, I can't make a triangle, okay? So not any 3 lengths will make a triangle. Any two sides added together has to be bigger than the third. So what this looks like on your paper would be like, can these lengths represent the side of a triangle? You're pretty much just checking, does 4 plus 5 equal something bigger than 6? Does 5 plus 6 add to something bigger than 4? And does 4 plus 6 add to something bigger than 5? And ultimately, this is the only one that we're actually interested in, because those are my 2 smallest numbers. Of course, 5 plus 6 is going to be bigger than 4 because 5 and 6 are already bigger than 4. 4 plus 6 is going to be bigger than 5 because 6 is already bigger than 5. This is the one that I'm interested in. Taking the 2 smallest, adding them together, making sure they're bigger than the third side. So 4 plus 5, is it actually bigger than 6? Yes. So 4, 5, and 6, inches, miles, centimeters, yards, like it doesn't matter, whatever that unit of measure is. If you have a length of 4, a length of 5, and a length of 6, you can make a triangle. So we already did A. I'm just kind of going down. I know this is D and G, but look, if we add the 3 plus 3 together, is it bigger than 7? No, 3 plus 3 is 6. It's not bigger than 7. So D cannot make a triangle. 6 plus 7 is bigger than 8, so we can end up making a triangle. So these are just yes or no questions. Can these lengths represent the side of a triangle? Add the 2 smaller ones, make sure they're bigger than the third one. All right, so hopefully you were able to move through those examples. All you were doing was checking the two smallest to see if it was bigger than the third side. This is now a question mark. Now we have a variable, okay? Well, if I have a side length of 15 and a side of 6, what are the possible ranges? What are the possible lengths that missing side could be to make it a triangle? And this is the part where it gets kind of tricky to draw, because I have something, like I have an X, I have a dashed line here. I tried to make a triangle, but it's possible that this side of 6 could actually be down here. And so this length of X to make that, let me see if I can just draw it. Like we're just pretending, like what if the 6 is actually here and this is my X value, okay? Or what if we open it up and make the 6, I can't even do it this way. Like we make the 6 out here, and then the X value is this ridiculously long side. So it's like we're either like closing the 6 and making it really close to the 15, so the X value connecting these two, okay, make this 15 and the 6. So the X value connecting these two could be really small, or I'm making the 6 the whole way out here and that side length is really, really long. I can't do that in a picture, okay? It's either, I have to draw it some way, but it technically could be this, or it could be this. So this is the math, okay? Don't think too much about it. This is what we do. It works every single time. You take the two numbers, you subtract them, take the two numbers, notice how I'm leaving a space, and add them, okay? 15 minus 6 is 9, 15 plus 6 is 21. The X value is literally somewhere between 9 and 21. Do not put equal to bars there. It is only less than symbols, and you have to do the subtraction first, leave space, and then do the addition, because that way this says that X has to be bigger than 9, but it has to be less than 21. Because if it's 9, then it's equal to, and I can't make the triangle. If it's less than 9, then it's gonna be equal to or shorter, and I can't actually make the triangle. Like if this is 8, it won't make a triangle, okay? And then if I spread it out here to get this bigger one, then it's possible that it's too big, okay? And it has to be less than 21, or else it can't make a triangle, okay? So understanding this conceptually can be a little bit tricky because of, being able to see that it's closed or open. The point is that the math is not that hard, okay? Subtract the numbers, add the numbers, and that's it. X is somewhere in between those two numbers. So when we get into problems like this, where there is no drawing, it's just find the range of the possible third side, you're just subtracting them, leave a space, add them, and then all you're doing, 7 and 17, right? All you're doing is putting the X in between with less than symbols. That's it. The X has to be somewhere between 7 and 17. Take the 25, subtract 20. Take the 25, add the 20. So you're going from 5 to 45. Like, that's how easy this is. Don't think that much about it. But of course, we're gonna put some harder algebra in it now, okay? What I still need you to remember is that this side with the X value is like the dash side, okay? I don't really know if that is a short side length or if it's a long side length. So you need to keep that in mind. The point is that the two sides that we do know, the 14 and the 27, we're still going to do the same concept with. We're going to subtract the numbers, 27 minus 14. We're going to add the numbers, 27 plus 14, but instead of putting just an X in the middle of their answers with two less than symbols, we're actually going to put in the 2X minus 5, okay, with the less than symbols. So this is what, 13, this is 41. So 2X minus 5, that side length has to be between 13 and 41. I don't know what x has to be yet, but I know that that side length has to be between 13 and 41, the same way that all those other ones did, between 13 and 41. Now we solve. Now this is algebra. Hopefully you guys remember solving these compound inequalities. We're gonna add 5 to all 3 sides. So we get 18 is less than 2x, which is less than 46. Divide by 2 on all 3 pieces. So we get 9 is less than x, which is less than 23. So the x value has to be between 9 and 23 in order to get the side lengths between 13 and 41. So this is your side lengths, your range for possible side lengths, and this is for x values. So if we didn't throw algebra in there with the expressions and things like that, it's just the subtracting and adding the numbers figures out that range to make the triangle. If we're gonna throw the algebra in there, you just gotta make sure you're solving that compound inequality. So this last one, anytime you have a missing side length, finding the range of the possible values of x, you're just gonna, these are the 2 sides that you know. Subtract them for the smallest value, add them for the biggest value that this side could possibly be, and then use that to solve for the 2x minus 1. So just like the last example, just a different algebraic expression. All right, so that concludes this video. Triangle inequalities started out first with the relationship between the angles and the side lengths that the angles create. That is an inequality because smaller sides create the smaller angles, and so you can order them from least to greatest. And so that's that idea of being being able to compare the side lengths or the angle measures. There's a relationship between the angle that it creates with the side, which is why isosceles triangles and equilateral triangles have the relationships that they do. Okay, and then we moved into the side lengths to actually create a triangle where any 2 sides has to be bigger than the sum of the third side, but we always just focus on the smaller 2 to make sure that it actually is bigger than that third side. And finding the range requires very easy, subtract the numbers, add the numbers, and that third side, that missing side, is somewhere in between those 2. Subtract them, add them. Okay, a little bit difficult to visualize, a little abstract, but the math itself is very straightforward. So don't overcomplicate that, okay? If you have questions, we'll work it out before your quiz. Thanks.